Hello, I'm really excited to talk to you about my Understanding by Design unit over a unit on slope in Algebra 1. So first I would like to give you a summary of the unit. Students will explore slope as a means to describe a point's relationship to another point. So basically they're going to be using several different discovery activities to look for patterns. They are going to look at the four different types of slope: positive, negative, undefined, and zero, and discussing patterns to make class rules and generalizations about those four types of slope. Once again, they will be using a discovery activity to determine the relationship between parallel and perpendicular lines. They will be coming up with class rules for finding the slope of lines and determining those relationships. And they will also explore slopes as rates of change in real life context, finishing up the unit with a big performance event that requires their knowledge of the real life application of rate of change. So in stage one, I looked at the desired results for my unit. And at first, I was looking at the Missouri Learning Standards for math, and I came up with 4 goals that I thought matched perfectly with this unit. First, I wanted my students to determine the average rate of change of a function over a specified interval and interpret the meaning. So that's where that rate of change in the real life context comes in. I also wanted them to be able to interpret the slope and the y-intercept in the context of the data. That's also those real life contexts that they'll be examining. And I wanted them to be able to determine that linear functions change by equal differences over equal intervals. That comes about when they are determining the slope formula. And lastly, I wanted them to develop definitions of perpendicular lines and parallel lines. So those last 2 objectives will both be utilized in our discovery activities that I will show later on in our lesson plans. Throughout the course, we discussed the importance of enduring understandings. These are where students will truly find transfer in the information that they're learning. So the enduring understandings that I came up with for my unit were linear functions represent situations involving a constant rate of change. The relationship between 2 lines can be determined by comparing characteristics of each line, and rates of change are used to describe any ratio of variables that remains constant. Which led me to these essential questions. What makes a relationship linear? What does the slope of a line tell you about the line or situation it represents itself? What could we not talk about if we did not have knowledge of rate of change? And what real-life situations would result in a model with parallel lines? Those last 2 questions I think are the most important because they really speak to the transferability of the information to real life for the students. Also in stage 1, I identified the information that I thought students needed to know and be able to do. So you can see that we have some key terms that we're looking at: the formula for calculating slope, which they will be determining in a class activity; the relationship between slopes of parallel and perpendicular lines, which will also be found in a discovery activity; 4 types of slope, which they will be able to use their creative minds to represent their understanding of; and the slope of any part of a line is the same as the slope of any other part of the line. And that's really important that students understand that slopes remain constant when you're talking about a true linear relationship. I also want my students to be able to do a couple of things. I want them to know how to calculate the slope given the graph or 2 points, and they'll use that formula that they determine in their discovery activity. Determine if 2 lines are parallel or perpendicular when given points, equations, or graphs of each line. Identify the independent and dependent variables in a situation. This really transfers over to science. The independent and dependent variables are really important when you're talking about experiments, and this is where the real life applications really start to come in. I want them to be able to find the rate of change over a designated interval of a linear model, find the constant term of a linear model, and graph lines with designated slopes. In stage 2, I thought long and hard about what kind of performance task I wanted my students to be able to complete. I wanted it to be real, and I wanted them to really have to think and do something unique with their product. So I came up with this scenario that they are going to be developing a commercial to try to convince consumers that their charger is the fastest on the market. So in the process of researching, they're going to determine what the minimum percentage they need in order to be fully charged by 3rd hour. So basically, they have to have a fully charged iPad by third class period. And that iPad, they wake up and they realize they forgot to plug it in. And so they have a portable charger and they have a wall charger. And different time periods throughout the morning, they can use different things. So for instance, while they're getting ready, they can plug it into the wall. They can use their portable charger on the bus, and they can plug it in again in first hour and use their portable charger in second hour, was the scenario that they were given. So in the process of figuring out what percentage they need to start the day with, they have to research and find the rate of change that their iPad charges on the portable charger and on the wall outlet. So they're going to have to actually plug their iPad in and figure out these two times. And then once they've figured that out, they take on the role of an action researcher. So they look into the rates of change and they actually are going to create a commercial to try to convince people that their portable charger is the fastest one on the market. So they're going to convince their classmates of that, and they also have to make their third hour teacher happy by bringing a fully charged iPad. So it's kind of two components. So they're going to be creating a commercial that includes all of their research results and convinces their classmates that their charger is the best on the market. And they will also create a plan to make sure their iPad is always charged for class. So it will be judged on a couple of components. I'll show you the rubric for that. So the components the criteria are data collection. So initial data includes charging times and amount of battery percentage gained during that time for both your wall charger and portable charger. Data is also collected by polling at least 3 classmates and or family and friends on the charging rates of their portable charger, so they have something to compare to in their commercial. And all data is credible and can be checked for accuracy. They are going to be graded on their rate of change calculation, so their rates need to correspond to the data that was collected and be calculated correctly. Their starting percentage calculation, so if they wake up and they need to have their waking time, the time spent on the way to school and in first and second classes, and then they need to figure out what their minimum percentage could be in order to get their iPad charged on time. And then lastly, their commercial needs to include all of their research and resulting charging rates, include at least 1 marketing technique and 3 reasons why their product is superior to others that they've researched. And that's where the talking to 3 other classmates and or family and friends comes in, so they have something to compare their product to. So there's some other evidence that we'll be looking at. We'll be taking some quizzes, homework and classwork, formatives, whiteboard work. We'll also take a summative at the end of the unit, and then they'll self-assess on the battery life before they turn in their project. They will be completing, and they will also reflect at the end of the unit as a class. They will be writing with the prompt, since learning rate of change, in what ways will you use it in real life, and how would life be different without the concept? So that goes back to that essential question we discussed at the beginning of the unit. Stage 3, we have some different learning experiences. So we're going to begin with an entry story about the hike my husband and I took on our honeymoon, talk about how steepness affects sprained ankles and other things. We'll introduce the essential questions, discuss the performance task. I'll hand out a key vocabulary sheet that they'll use throughout the unit, and we will send out a link to a Quizlet set on Google Classroom so they can use that to study that vocab. I will do the presentation on the slope dude lesson, and then we will have students present their products showing their types of slopes. And then we will present slope as a number lesson, complete the slope scavenger hunt to practice and review finding slope. We'll actually take a 3-color quiz over finding slope, in which they get to use their resources and their classmates to help them fill out that quiz. We'll present the parallel and perpendicular lines discovery lesson, and then we'll review and discuss using the questions listed. Present rate of change lesson, and then students will each write a word problem to find a rate of change in the real world context, and we'll use those to discuss and review for our final. And then students will take a quiz over all of the slope components learned so far. They will start on their battery life performance task. After they finish that task, they'll fill out a rubric and self-assess before submitting, and then they'll use the review questions we created earlier in the unit to review for their summative. After they complete their summatives, it will reflect by answering the writing prompt that we mentioned just a minute ago. So I've highlighted 3 lessons that I think are very important in this unit, and the first one is called Slope Dude, Introduction to Slope. And so they will start by writing down the definition for slope that they have in already coming into the unit. And then they will watch videos to help them refine their definitions. We will do a Quizlet Live to check understanding after watching those videos. And then students will actually get to pick a product on how they show their understanding of the 4 types of slope. So they can do a comic strip, they can do a voiceover video, or they can choose another way to show that understanding. And that lesson will be differentiated because students can show their individual strengths through their choice of their product. And I also, for all of these, differentiation for struggling students is we have resource time in which students can come in and get extra help. In my Discovering Slope as a Number lesson, we'll watch a video about slope and then have a class discussion about steepness. And then we will use some different tools in class to develop a rule for describing steepness. And then they will rotate through stations. And this is where the differentiation comes here. These station groups are based on pretest results. So as they rotate throughout these 3 stations, they will get more or less instruction as needed based on their level of understanding. So the 3 stations are discovering the formula for slope. So struggling students will do less discovering there and they will have more direct instruction. Then they will watch a video about slope, take notes, and then complete online practice. And then at the end, once everybody has rotated through those stations, we will do a quizzes to check understanding, and they will do some independent practice. In our parallel and perpendicular discovery activity, we'll start with Kahoot and class discussion about looking at lines being parallel and perpendicular and what that means. And then we'll work in pairs to discover some similarities between the relationships of parallel and perpendicular lines. And based on that discovery sheet, we will develop class definitions of the relationship between lines. And then lastly, we will do a Go formative assignment before doing independent practice. During this lesson, struggling students will receive more direct instruction, and advanced learners can actually skip the independent practice and work on real-life examples to be used in future lessons for the class. And that is a look at the unit that I've created for slope. My hope is that at the end of the unit, the students have a real understanding and transferability of that information that they've learned. Thank you.